Good evening, everybody. First of all, thank you very much for staying at the end of the day. It's been a long day for you, I know that, and we appreciate a lot, so you can stay to the talk. So it's a pleasure for us to be here to talk a little bit about cloud-native Buildpacks project, especially in how you could use it in your organization to quick and secure image builds to be deployed on any Kubernetes environment or OCI runtime environment. My name is Juan Bustamante. I'm a platform maintainer at the Buildpacks project. I also worked for the company named DBAccess. And with me is the amazing Aidan Delaney, which also a learning maintainer at the project and working from Bloomberg. A quick agenda for today is we will be discussing a little bit, like 8-10 minutes, about what Buildpacks is, how it works. I will try to go through a few demos so you can see it in action. Then we will try to explain you a little bit from the three main personas we identify as the main users, like end user and applications end users or Buildpacks authors and platform operators. Aidan will talk to you about a little bit benefits and stuff we have for them. And we will conclude with some fast rebuilds and secure image stuff. Okay, so let's get started. Okay, so in essence, the cloud-native Buildpacks project allows you to transform your application source code into a production-ready OCI image that can be deployed on any OCI runtime environment, like Kubernetes or maybe your Podman or Docker instance locally, whatever. And we offer a reference implementation of the specification we also maintain. These implementations are the Pack CLI or the Kpack CLI. You can use it. And what we do is we can take almost any programming language, like Go, Java, Python, Node, Rust, and using this CLI tool like Kpack, like Pack or Kpack, we will produce an OCI image with a very defined and organized set of layers. It will start with the run image layer, okay, containing the operating system that you need for your application to be executed, followed by the runtime layer of I don't know, your programming language. For example, if you are running a Java application, maybe the JDK will be in that layer. Then some dependencies, it will contain all the things that you need to run your applications. And finally, the application layer we will get that will contain everything we get from building your source code. Okay? All this without needing a Docker file. Okay? We don't need the Docker file to build this application image. And that's very important because applications that handles probably hundreds or thousands of workloads with different teams, with different development teams running different applications on any language, a Docker file could be a nightmare for the platform operators. Okay? People that it's been there could recognize the value of the Buildpacks project. Okay? Another important thing to notice here is the cloud-native Buildpacks will always keep a well-defined boundary between each layers category, right? And that allows you to offer a feature like rebase. And that's very powerful also, and Aidan will talk a little bit about that in a few minutes, okay? So let's see 3 very quick examples to give you a very brief idea of what cloud-native Buildpacks can do for you. Let's start with monorepo application. We have a backend written in Go. Then we have also a Node.js front end in TypeScript. We're going to use some Paketo Buildpacks collection, and we're going to use too the Pack CLI. And we're going to run just a simple command, pack build. Example is going to be the name of the application image. And then using this builder, Paketo, builder Yummy base is basically a flag to tell pack, hey, please use this builder. And you're going to see why, and that's important, OK? Let's see. OK, you can see that it's very small for me here, but let me see if I can pause it. OK, no. OK. OK, I'm sorry. OK, so what we're doing here is basically you have the source code. I show you like the structure. We run pack build there. And what's going to happen is we're going to detect that this is a Go and a TypeScript application. And we're going to run the Buildpacks inside the builder, the Paketo builder. And we're going to compile everything, right? And it takes a little bit. So at the end of the whole process, an application image is going to be pushed. I believe I run this one on my local, so it's going to be saved on the Docker, on the Docker daemon. And basically, it's going to be composed with all the layers that I mentioned before. We're going to have the run image. We're going to have the Go dependencies, the Node.js dependencies, the application, and everything. Once we have done that, what we're going to do is just to run two containers, the same image, the same application image with two different entry points, one for the back end, one for the front end, okay? And then we're just going to go to the web browser, open the web application, and in the bottom you will see a little message. That message came from the backend running in Go. So it was really fast because obviously I don't want anything going wrong during the demo, but that's the important thing on the example, okay? It's the same application image. It was executed with two different entry points, one to run the backend component and one to run the front-end component, okay? And the image was just built using the pack build command, right? Okay. Sure. Okay. Now, let's go with another demo. This is a Spring Boot application, a Java application. Everybody knows about it. In this case, what we're going to do is run pack build pet clinic, and I'm going not to use the builder flag. Why I'm doing it in this way? Basically because I just configure my pack CLI to use the Paketo builder as the default builder. So I don't have to, pass through this flag. And it's going to be a little more easy for developers to do it. What's going behind the scenes is the same thing. We're going to inspect the code. We are going to see that it's a Java application, and we're going to apply all the Java build packs from the Paketo builder and produce the application image at the end. Then we're going to just run it, Docker run, nothing mysterious about it. And then we're going to go to the browser, and hopefully you will see the pet clinic application up and running, okay? Nice. So same command, pack build, for two different applications using the same builder in this case, right? Now, the third one, it's a Python application I generated with AI because, it's fun. So if we want to build it, which command we should use? Pack build, right? Nothing weird. So let's do that. That's it. Same builder. I believe there is just one flag there to say, hey, use this Python version. And that's it. We just build the code. I can see it. Oh, yeah, it's building it. OK. And at the end of that, we will just run it and see the Python application up and running. OK, so here, the important thing is you don't need the Docker file. The app images that are being generated are optimized for production. And that's a benefit of using the Paketo or the Heroku collection of Buildpacks. And that's something that you don't need to care, and when you're using Docker files, you do need to care on how to optimize your application image. This is something that we can get from the community and from the, specifically from the Paketo team, okay? Sweet. So now, Aidan, it's gonna give you more helpful insights.
Fantastic. Thank you, Juan. Oh, I see the screen has got a horrible contrast. Unreadable on the laptop. Fantastic. Anyone knows how to use computers, please let us know how to turn up the contrast on this. So, as Juan said at the start, we kind of think that there are 3 different audiences in the room who are interested in Buildpacks. There'll be some of you who are application authors. So in my day job, I write applications. I'm an end user of Buildpacks. There will be some of you who are actual Buildpacks authors. I recognize a few faces in the room. We know and love you, and thank you for everything you've done with us. We'll talk to you folks probably individually at the booth. And then there's a whole section of this audience who are probably what we call platform operators. So folks who actually build images for other teams in their organizations. Those are the 3 audiences that we kind of want to update today on what's happened in the Buildpacks world over the past year. From the end user's perspective, I appreciate it's slightly complex looking. Right, we're Buildpacks project, the cloud native Buildpacks project. We're at buildpacks.io, and we maintain a specification. And the specification is at that Git URL. You can change that specification if you want to come along to our meetings and suggest improvements to it. We also provide the pack and kpack tools for people to use the Buildpacks. However, the actual implementations of the Buildpacks come from downstream providers. So the Paketo team, it's an open source project. They maintain a suite of Buildpacks for building various language groups. Heroku, where some of this technology originally came from, they maintain a set of Buildpacks that they use to build certain language groups that they support. And then Google use Buildpacks on Google Cloud Run. So the set of Buildpacks that they provide are particularly optimized for building images to run on Google Cloud Run. From the changes from end users' perspective over the past year, because this is a maintainer track talk, first of all, I know it's late, but hands up if you've ever heard of Windows. I'm not joking. Hands up in the air if you haven't ever heard of Windows. Some people have never heard of Windows. I doubt that. Keep your hands up, though, if you've heard of Windows containers. Right, it's a smaller number than the people who've heard about Windows. It doesn't surprise me. Windows containers on Windows is a really interesting technology from Microsoft to run applications in Windows on containers environment in Windows. We have dropped support, or we've deprecated support for that. And the reason that we've deprecated support for that is not because we don't like it, it's just we had no users. There have been 0 users for that over the past number of years. If you are users who are interested in those features, please come and talk to us, because we haven't removed the code yet, and we have the ability to undeprecate support for that. But we have no support, we have no users for it, and it was taking development time away from other things, so I'm afraid we've just deprecated support. Prior to last year, we had our own magical way of providing image annotations. It worked, it was great, but now we support the kind of standard OCI image annotation stuff. So great. If you annotate your images in a certain way, it's all now supported in Buildpacks. If you're a long-time Buildpacks user for the past 4 or 5 years, we've been around for about 10 years. So if you've been using it for 4 or 5 years, then you'll be aware that we deprecated stacks a few years ago, and we've cleaned up the documentation around what that means now, because stacks have just gone away from pretty much all implementations. And as of yesterday? Yeah,
Monday.
Monday, I can't remember what day it is. As of Monday, we now have an actual roadmap for the first half of 2025 so that you can read on RRCs. All the features in there are in development, so we've already put stuff in there that we're fairly confident we're going to finish soonish. But it is an open source project, and people come to and from the project at their own volition. So, it may not be quite the first half of 2025. You might get delivered in the second half a bit. And because you're end users, or some of your end users at least, you will be interested in what's going on in the downstream projects, which we've just summarized 2 of the change sets here from downstream projects. So as a Buildpacks user, I use Buildpacks with the Paketo builder, or I use Buildpacks with the Heroku builder to build my applications. The Paketo folks have some really interesting features. In the past year, they've pulled in dependency mirrors. I'm a big fan of this feature, which means is that if I mirror PyPy or NPM or Maven internally in my organization, a lot of us are doing that these days because we've got requirements to keep control over our dependencies, so we're mirroring those internally in our organizations. The bog standard build packs that I pull from Paketo now will allow me to point the build packs at the internal mirrors. So they're not going to pull dependencies from upstream. And this is a big, useful thing for me. And the Paketo folks, Juan demonstrated the Paketo build packs using their Jammy-based builder. We're slightly old school. But they've announced support for a UBI-based builder, a RHEL image. If you're a Red Hat customer, then that will probably be of interest to you. But they've also announced a new Ubuntu Core-based image for things. So their builders are going to be based on Ubuntu Core, right up to date. And they've got clearer maintainer status about the build packs. One of the things that they noticed in the past year is that they need more maintainers. So things that have active maintainership are now indicated quite neatly, and things that have less active maintainership is being indicated. It is an open source project. They're looking for maintainers. They have a booth downstairs as well, so talk to them. They're good folks to get to work with. From the Heroku folks, it was easier getting information from them because they brought us to dinner last night. So I'm really happy. But they now have a really nice new, shiny new build pack for .NET. They've added Poetry support to their Python collection of build packs. So now if you use Poetry instead of using Simple Build or one of the other Python backends for building, then they've got your back. They have a really, really neat new build pack for installing Debian packages in images. This was something that traditionally build packs have had poor coverage of. And now I think we're getting to the stage where we understand the problem and we can actually give decent mechanisms for installing operating system packages. So I haven't looked into this yet, but I'm seriously intrigued, and that's what I'm going to be spending my weekend doing. And of course, all the Heroku build packs these days are multi-architecture. So they can build AMD 64 or ARM 64 images. When I say multi-architecture, we're generally not talking about Sun or AIX these days. But, you know, we can get support for that if you really want it. So if you're a Buildpacks end user, that's the kind of things that have changed over the past year. If you're a Buildpacks author, you're probably well aware of the changes because you've worked with us quite closely on things around spec changes. One of the things that you can rely on as a Buildpacks author is we introduced a feature that we call extensions. I remembered it because it was written on the slide. We introduced a feature called extensions about a year ago, maybe 2 years ago at this stage. That's gone GA now, so it's now part of the standard. It's not behind a feature flag anymore. So as a Buildpacks author, you can use extensions and rely on them. And the other thing that we've changed in the past year is now we have better support for insecure registries, which sounds like an anti-feature. But actually, if you're a Buildpacks author and you just want to just upload stuff to your local registry running on localhost port 5000, then having support for insecure registries is really neat. Well, it just speeds up that development loop for Buildpacks authors. But I suspect the vast majority of you folks in the room are what we call platform operators. If you're kind of a DevOps person, if you are, what's the new term? We call ourselves platform engineers now, don't we? If you're a platform engineer building a platform, if you're the kind of person who in your company you help other people build OCI images, and like Juan, I use the term OCI image rather than Docker image because we tend to talk about the standard rather than Docker's excellent implementation, but we rely on the standard. So if you're one of those folks who helps others build images, we would call you a platform operator. And we have 2 tools, as Juan said, to help you build images for folks. First one is KPack. The K stands for? Yes, Kubernetes, you got it. Of course. K is our Kubernetes operator, and it'll sit there, it will monitor your Git repositories. I think it might have Mercurial support as well, but I've never used it. It'll sit there, it'll monitor your Git repositories, and once there's a change to the main branch or your nominated branch, it will just build an image for you. and stick it in your registry. And it's a really nice way of building images for folks. It's got another bunch of other advantages that I won't go through today, but talk to us in the booth tomorrow morning if you're interested in the other advantages of that. We got to announce it last year, didn't we?
Yeah.
In the EU, that KPAC had released the latest KPAC version at that stage had SALSA level 3 support. So if you're into your software supply chain security area, which a lot of us are these days because of various regulations, this is the highest level of software supply chain security that you can achieve under that particular mechanism or that particular specification of supply chain security. So it still has that SALSA level 3 compliance, and it's a good thing. PAC is a CLI that Juan demonstrated at the start. It does integrate with common workflows. So anywhere where you're currently building an image using other tools, Co, Jib, Docker, whatever, you can probably just parachute in PAC. I'll say probably because nothing's easy, is it? But we have documentation and examples around using PAC within Circle CI. So if you're a Circle CI user, we can give you an orb and you can use PAC to build images. Or if you're using GitHub, and if you use GitHub Actions to build your images, well, we've got a GitHub action that will let you use PAC to build images. And you can try it very easily. There's very little risk in trying it. GitLab, of course, GitLab workflows. We've got tooling, and we've got examples and documentation to show you how to integrate PAC with that. I have not linked Jenkins to anything, because every single Jenkins instance I have come across in my entire life, and Jenkins is now older than me, I swear, is that the Jenkins pipelines in every organization are different. So I can't tell you one way of integrating it with Jenkins. Sufficing to say that I've not found a Jenkins pipeline yet that I couldn't put PAC into. So, talk to us in the booth tomorrow, please, if you're interested in integrating PAC with your Jenkins pipelines. And we've also got Tekton support as well. So if you're using Tekton as your build automation infrastructure, PAC will just drop in there and generate images for you. So it's cheap to try, giving all the different workflows that we help support. Right, so as a DevOps team or as a team of platform engineers, what I want, so kind of as a platform engineer, what I want in a build system is control over the base images. I want to give engineers the ability to experiment with new base images, but when it comes to our production pipelines, I want control over that. The organization wants control over those base images. And as we've kind of hinted at, you can have control over the base images that you use. You can use your own base image by building your own builder. We have some samples in our, we have some demo samples in our documentation that explains how to do that. Please do not use our demo samples for anything production related. Do use the Paketo or Heroku Buildpacks for production stuff. Our samples are there really as sample code, but they just show you how to build your own custom builder, and you could reuse the Paketo or Heroku Buildpacks in your custom builder and maintain that production level quality. It's straightforward to do. There's a builder.toml file. Everything's either toml or YAML these days. And instead of using the build and run images that's mentioned in that, you change it to your own build and run images. Then you use PAC to rebuild the builder. It's pretty straightforward. But that means that I get to keep control of the base images that are used in my organization. Similarly, I want control over the versions of tools. Again, my end user developers can experiment with whatever tools that they want, but in the production pipeline, the organization needs to have control over the tools that we're using. Need to know exactly what JDKs we support in production. I need to know exactly what Python runtimes we support in production. They may be different. We might not support Python 3.13. I think that's the latest version right now in production. We might only support Python 3.12, and that's your decision as the platform engineering team. And it might take you 6 months to adopt 3.13 for various operational reasons. And again, Buildpacks support that by, again, providing a builder to your build system that would pull in the version of the Heroku or the Paketo Buildpacks that support the latest tooling that you want to support. You don't have to go with the latest, greatest stuff. You can hang back 6 months or choose the policy that you want to implement yourself. Similarly, I want control over the language families that we support in production. I like Rust, but maybe we, for a policy reason, decide that we can't support Rust in production right now. So I would create a builder that has my base image, has the versions of the tool chains that I want, and maybe I would only allow on my builder support for .NET and Node.js. And the reason for that was because those will be the two language stacks that we choose to support in production. Your organization will choose different language stacks, and we have the flexibility in the framework for you to be able to choose those language stacks. And not finally, but close to finally, and I've forgotten how many slides I've got left, and I've lost my phone, it's here. I've got 5 minutes, no way. Time's flying. What we've got is control over the build environment. Again, I mentioned that it's common these days, particularly in regulated businesses, for us to mirror our dependencies internally into internal mirrors. I want a mechanism to ensure that our production images always only build using those internal mirrors, and that end-user developers, as well-meaning as they might be, cannot refer to other pip allocations, for example. And we do this by creating non-overridable environment variables on the base image, which is in my control because I'm the platform operator in this case. So I might expose a pip index URL that developers must use, which will point at our internal mirror. And again, there's an example in our samples directory folder as of this morning, which is good. So we can, other environment variables that you might want to drop in here is a Go proxy, or your npm config registry, or your Maven registry that you use internally. So what we're doing is we're building production images, and we've got the flexibility to let developers do whatever they want on their local machines, but in the production build pipelines, I control this, and they can't overwrite pulling things from public registries, for example, so we know what's on our images. I've got about 4 minutes left. Custom build packs I'm going to skip because it's slightly more advanced. But the anatomy of an output image, this is the output image that Juan generated earlier on. What you can see is that the layers are small. They're very well defined. The layers are only as big as they need to be. There's a layer called Node, which contains only the Node.js engine, and it is 165 megs. This has, the fact that we build these very, very small layers has a lot of advantages in terms of fast rebuilds. It also has a bunch of advantages in terms of application security. For example, first 3 layers there are unlabeled. They're from the Ubuntu base image. We can rebase onto a new Ubuntu base image without rebuilding the image. It is a registry-only operation, meaning that if there's a CVE found in the base image, which often happens, I can upload a new base image to our registry, and I can effectively rewrite the manifests so that we rebase onto that new base image. Similarly, if there's a problem with the targets layer, which is my Go binary, but there's no problems with the other layers, I only need to rebuild that layer. I don't need to rebuild the Node.js. So we have this fast caching stuff, pretty advanced caching strategies, which does lead to fast rebuilds. I've got to skip the slide because I've already said whatever I want to do there. And in terms of the secure stuff, if you refer back to that past slide, Juan lied to us earlier. He didn't go into all the details. And one of the things you can see here is that there's an SBOM, software bill of materials, that's stuck onto all the images. So all the images have software bills of materials, which allows us to have these small and focused layers. Because we've got SBOMs, we can tell exactly when CVEs arise which images the CVEs actually affect, and it's no longer guesswork. And if you've got the operational ability, you can also tell where the images with those CVEs are deployed, on what pods in which clusters. Now, it's pretty advanced, but it does allow us to easily remediate CVE issues when they come across. Fast rebuilds and just redeploy the application quickly. And of course, all this stuff, Kpack ships with cosign support by default, and Pack integrates quite neatly with the in-toto tooling, stuff like Witness to generate provenance certificates for the things that you're building. And again, these are important, particularly in highly regulated environments. And I'm going to conclude before she throws me off the stage. Buildpacks project is in quite a nice, healthy state at the moment. We feel like we're in control of where we're going in our own destiny, which is good. We've had small updates to the spec over the past year. No major spec breaking changes. So we're happy with that. The Buildpacks implementations, the stuff from Paketo, the stuff from Heroku, stuff from Google, although I didn't put it up here, seem to be in a very stable and healthy state. You know, the Heroku stuff is only getting more features. The Paketo folks are sorting out their maturity model, which is brilliant. And I hope what we've demonstrated as well, that you can use Buildpacks and the features in Buildpacks to give your organization a lot of control over the workflows by centralizing it into a DevOps or platform engineering team, but it doesn't take away the ability of your engineers to experiment with maybe a dev-only builder that you can provide with the latest, greatest tooling on it. You can find us on the internet at all these places, and like all CNCF open source projects, we have a weekly meeting that you can join, and you can control how the project goes. Thank you very much. I know it's been a late one, and we're free to take questions now from anyone.
Okay, no questions. So thank you, guys.
Yeah, the pavilion booth thing is on right now, I think, which is why a lot of people are rushing out the door, and I'm rushing down there as well because we've got the Buildpacks booth down there. So please come along and ask us questions if you want to. Thank you very much.